In this video, we're going to discuss what we call linear inequalities. So we've already discussed how we solve linear equations, and we looked at applications that are involving linear equations. Now we're going to get to linear inequalities. And one thing that I always want you to remember is that we're going to be using our inequality symbols here, right? Remember, we have our less than or equal to. We have our greater than, and then we have our greater than or equal to symbols, all right? And so we're going to use these symbols to help us solve linear inequalities. Basically, the definition of a linear inequality is basically an inequality containing linear expression. So I can write an example of one, something like 2x plus 4 is greater than 3. Right? Notice here that this is a linear expression since the only exponent on the variable is 1. All right, and so that makes this a linear inequality. Here we see our inequality symbol here. All right, before we actually get to solving linear inequalities, I want to be able to express my solution. Right? When we were dealing with equations, we had an equal sign, so we knew exactly what x equal, our variable equal. When we have linear inequalities, almost all of them have infinitely many solutions. And so if I have infinitely many solutions, that means I have a lot of solutions. I need to be able to show you all the solutions that I have. All right. And one way to do that is to plot the solutions on a number line. All right. And so when I plot my solutions on a number line, this is what I'm going to do. I'm going to draw me a number line if one is not given to me. And I'm going to plot the number on the number line. All right. But I got to be careful when I plot. Notice that some inequalities have the equal sign, as in these two right here, and some of them don't, right? For instance, if I have 3 is greater than or equal to 3, this would be true, right? That means that 3 is a solution because I have this equal to sign. 3 is greater than or equal to 3 because I have that equal to sign. But if I didn't, if I had 3 is greater than 3, that would be false. And that means that this 3 would not be a part of my solution. All right, and so when I look at inequalities, when I have this equal sign, what I'm going to do is I'm going to use a closed circle. That means that the number that I'm using is a part of my solution. I would get a true statement if I substitute it back in. And I'll use an open circle when I don't see the equal sign for these types of inequalities here, a less than or a greater than. All right. Once I plot it, I'll have to shade in the right direction because I have a greater than. Numbers that are greater than a number is going to be to the right, and numbers that are less than are going to be to the left, right? And so I'm going to look at this first example here. I have in part A, I want to graph each solution on the number line. X is greater than or equal to -3, okay? X is greater than or equal to -3, right? Notice that this equal sign is under that greater than symbol, right? That means when I go to my number line at -3, I want to use a closed circle to plot that line. All right, and that closed circle just lets me know that -3 actually works, right? So if I were to replace -3x with -3, I get -3 is greater than or equal to -3, and that is true, right? And so that is exactly why I'm going to use a closed circle here. Now I've got a shade. Now that I have my number plotted with a closed circle, I need to shade. Well, x is greater than or equal to 3. Values that are greater than or equal to 3 are to the right of -3. Sorry, I keep saying 3, I mean -3. So I'm going to shade to the right. And I know it looks messy, but this is how I show my solution. And so what this is basically saying is that my solution includes any number that's shaded, including this -3 that's a closed circle. All right? So 3 would work, 4 would work, 0, -1, -2. Any number in that shaded region is a solution. I can substitute it back into this inequality here, and I get a true statement. All right, that's one way that we can show our solution. Another way that we can show our solution is by using what we call interval notation. Okay. Interval notation is using left and right endpoints of a solution set. And I use endpoints lightly because sometimes our solution set does not have an endpoint. Our number line continues to the right and to the left. For instance, if I look here, this is not really an endpoint, right? It continues, and so that's why I put the endpoint thing in quotations. All right? But I'm going to use my left and right in quote-unquote endpoints of my solution set, and just use those two numbers separated by a comma, and we're going to either enclose them with a parenthesis, or we're going to enclose it with a square brackets, right? Remember, your parentheses looks like that, and square brackets, And square brackets look like this. All right, the way you determine whether you're going to use a parentheses or a square bracket, you always use parentheses if you have a less than, greater than, or an infinity or negative infinity. And you're going to use a square bracket for less than or equal to or greater than or equal to. And we'll look at multiple examples of how we determine this. Let's look at this first example here. It says graph the inequality and write the solution in interval notation. All right. And my inequality that I'm going to graph is x is less than 2. All right. Well, x is less than 2. Notice I don't have that equal sign. So when I plot my point at 2, I'm going to have an open circle. Okay. And since I have that open circle there, now I'm ready to shade values that are less than 2, right, or to the left. For instance, 1. 1 is less than 2. So I got to shade in this direction over here. And so this is where my solution lies, on this side of my number line. And so if I want to write this in interval notation, anytime I extend to the left over here indefinitely, right? I'm extending to the left indefinitely here. It's going to continue. It's just going to continue, right? That means I'm having a negative infinity. And I'm going to include all of these points all the way until I get to 2. Okay? Every time I put an infinity or a negative infinity, I'm going to use a parentheses. But anytime I have an open circle, that's going to let me know that I have a parentheses when I write in interval notation. That means I don't include that number there. Had I extended indefinitely to the right here, I would have used a positive infinity instead of a negative infinity. All right, so that's the difference between positive infinity and negative infinity. Now that we can write our solutions in interval notation and graph them on the number line, it's time to get to solving these equations here. All right, and so what I want to look at here is solving how we solve linear equations. All right, the nice thing about this is going to be very similar to solving linear equations. So everything that we've done with linear equations before, we're going to do with linear inequalities. The only exception to that is that when you multiply or divide, notice these words, multiply or divide, by a negative number, you must flip the inequality symbol, right? So as long as you multiply or divide by a negative number, you have to remember to flip the inequality symbol. Well, let's look at an example. All right, in this example, our instructions are to solve each inequality and then graph the solution on the number line and write the solution in interval notation. I have negative 5x plus 7 is less than 32. All right. Well, if this was an equal sign, right, the first thing that we would do is subtract 7 from both sides. So that's what I'm going to do here, right? When I subtract 7, they cancel. I get a negative 5x is less than 25. Notice here, in order for me to solve for x, I got to divide both sides by negative 5. And when I divide both sides by negative 5, right, I get an x here. Since I divided by a negative, instead of using my less than, I'm going to use a greater than. And 25 divided by negative 5 is a negative 5. So we get the inequality x is greater than negative 5. So we've gone through the process of isolating the x. So you still go through that process. Once x is isolated, you draw your solution on the number line and you write your answer in interval notation, right? So x is greater than negative 5. On my number line, I'm going to go to negative 5 and I'm going to use an open circle since that's just a greater than. So don't close that circle. And values that are greater than negative 5 are to the right. And so I'm going to shade to the right, shade to the right. So I have my answer. Any of these numbers that's shaded, excluding that negative 5, since it's open, is considered a solution. Now I'm going to write my solution in interval notation, right? This is my left endpoint, and this is my right endpoint. All right, so from left to right, I start with negative 5, and I continue indefinitely to the right, and so that's going to give me a positive infinity. Notice you don't have to write the plus sign, but you always have to write the negative sign. Anytime we have a infinity, we always use a parentheses. And since that's an open circle and that's a a greater than without a equal sign, I have to use parentheses around that negative 5, right? So my solution set in interval notation is from negative 5 to positive infinity. All right, that's solving linear inequalities, and they can get a little bit more complicated. We will see more examples like that in class. All right, compound inequalities. Right? Compound inequalities are inequality statements with more than one inequality. And there's basically two types. There's one that's separated by the word or, and one that's not, it doesn't have the word and in it, but it's kind of notating an and inequality. Let's look at the or inequality first. All right, in this example, we're going to solve the compound inequality. We're going to present the solution on the number line and in interval notation. I have 2x plus 7 is less than 9, or 3x minus 8 is greater than 13. All right, I'm going to solve these very, very similarly to solving equations. I have to do both of them. But the thing is, when I do my solution on a number line, I have to use one single number line, and then I'll get to the interval notation after that. All right, so in order for me to solve the 2x plus 7 is less than 9, what I'm going to do here is I'm going to subtract 7 from both sides. I get 2x is less than 2, right? 9 minus 7 is 2. And last but not least, I divide both sides by 2. Notice that's a positive 2 that I'm dividing both sides by. And so I keep my inequality symbol the same way, right? So it stays a less than. All right, and so this one is solved for x. Now I'm going to go to the other one to solve for x. I add 8 to both sides. I get 3x is greater than 21. Let's divide both sides by 3, and we'll get that x is greater than 7. And so this one is solved, right? Remember, they're separated by the word or. And so if I want to graph this solution on a number line, right, I'm going to have x is less than 1. So notice that's a less than. That's not a less than or equal to. So I'm going to have an open circle at 1. And values that are less are to the left. So I'm going to put an arrow up here first so that I know that I have to shade to the left. All right, I'm going to go to x is greater than 7. Well, that doesn't have an equal sign either. And values that are greater than 7 are to the right. So when I shade, I'm going to shade to the right of 7. And I'm going to shade to the left of 1. Now, if you notice here, I actually have more than one interval, right? So this interval right here, this is the left end point for this one. This one is the right end point for that one. Okay? And this one also has a left end point and a right end point. And so when I write my interval notation, notice I'm extending indefinitely from the left. So that's going to be negative infinity, comma, and it continues all the way until I get to 1. Notice I use parentheses around both of these. And then this interval here starts at 7, and it's going to continue indefinitely to the right. So that'll be a positive infinity. Again, you can write the plus sign if you want. But when you enter your answer online, don't put the plus there. And I'll use parentheses around those as well. This or symbol makes us realize that our solution is either going to be in this interval here or that interval there. Anytime I have more than one interval in my solution, I use this symbol right here. And this symbol is called our union symbol. It just represents the word or. Okay? All right? And so that's how we solve an or inequality. Now what I want to do is get to solving an and inequality and show you how it looks. All right, so this is how an and inequality would look. Notice you don't see the word and, but you do see your variable kind of stuck between two inequalities. All right, so this is saying that, you know, this 3x plus 8 is greater than or equal to negative 10 and it's less than 14, right? You can read it that way, or you can just read it as negative 10 is less than or equal to 3x plus 8 is less than 14. When we solve these types of inequalities here, we're going to do the same thing, but we have 3 pieces. All right. So instead of working with 2 sides, we're working with, I guess you can say, 3 sides. All right. Even though it's not really 3 sides, it's 3 pieces. Right. But for me to start solving this for x, I need to subtract 8 from this middle piece. Right. And if I do it to that middle piece, I have to do it to this end piece and this end piece here. All right. And then I get a negative 18 is less than or equal to, right, those 8's cancel. And then 14 minus 8 is, oh, I left the 3x out. And then the 14 minus 8 is 6. Okay, that's still not solved for x. And that's a positive 3 here. All right, in order for me to solve for x, I got to divide each piece by 3. And I get a negative 18 divided by 3, which is a negative 6. These 3's cancel here. And 6 divided by 3 is 2. So I get these inequalities here, right? This is saying negative 6 is less than x. One way you can read that is saying that x is greater than negative 6, if you wanted to do it that way. And then this one is read the normal way, x is less than 2. Okay? So I'm going to go to my number line at negative 6. I'm going to have an open circle. And x is greater than negative 6, so I need to shade that way. I'm going to put an arrow. And then at 2, x is less than 2, open circle at 2. And values that are less than 2 are to the left. So this inequality is going to be kind of like an in-between. You're going to be shading in between to get your solution. And that means that when I write my interval notation, I'm only going to have one interval. And this is going to be my left endpoint. And this is going to be my right endpoint. Alright, and so my left endpoint starts at negative 6. And it continues until I get to 2. Alright, notice this is an open circle. I don't include it, so I use a parentheses. This is an open circle here, no equal sign, so I use a parentheses around 2 as well. Alright, and so this is my solution. Alright, that concludes our video on solving linear inequalities.